Could be just me. So, someone share their research results. Where do you add the oomph? Where do you put the accent?
I think 9 o'clock.
Yeah, show.
In the front or at the back? And it's between your circle.
Show. Stop at that moment that you feel where you add the oomph there. Okay. So there's one set of results.
Because it feels that that's where my pelvis drives forward.
Great. There's even rationale. Excellent. Anybody else have something different? Show me. Show. Where? Because that way I've got a really clear image where you mean. Show me. There. Okay. So pretty close. Yeah. Good. We're getting a nice little graph happening. Yeah. Show me. Where do you stop? Where do you stop where you add the oomph? Where is it? Right there. Great. Yep. Good. Anybody else have something completely different? No. Excellent. So somewhere back here you add the oomph. And when I was watching you before, even before you went out, when I asked you where do you put the accent, it was clear watching in the room where the accent was. Yeah. So knowing that, remember when you were watching the video yesterday and watching that little short guy on the floor? Remember how he brought the arm underneath and went and around himself to get that speed? Do you remember seeing that? Same place. Interesting. Even though he kind of bent the arm to bring it through, same place. So what is it about this hip-arm relationship that is so prominent in human beings? This business of, at a particular time, you turn the hip and it just whips the arm. Oh, was it? Okay, didn't pick that. It looked like golf. It's walking, yeah. It's running.
It's running from your brain system.
So, so our structure and our function are intertwined. This ability to turn around your own axis didn't come out of nowhere. This ability to have a really free shoulder girdle didn't come out of nowhere. It came out of our interaction of our living being with the environment. And if you believe that story, excuse me for those of you who don't believe that story, it is a belief. As we came out of the trees and stopped swinging around, well, then we found another way to organize our locomotion. Very efficient, just around a central axis. Yes, just around the center. And so when you strip this movement right down to its essence, the only thing you really need is to spin around your axis. Remember that lady in the maroon yesterday? The lady in red over there, that one. Remember her? Yeah, remember she just turned around herself, like, chip, 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 chip. Wow. There's a lot of power in there, and this is where human beings get their power from the ability to whip around your central axis, motivating it from the hip. And, boxers can throw a knockout punch just with a little. Balls can be thrown at almost 120 miles an hour in the United States with baseball pitches, just from a whip. Phenomenal. Yep. Matadors can do their things, dodging the bull with just a little turn. Yep, I hear a question. Is that an arm up in the air there? Oh, was that a whipping or was that? Okay, no, okay. Yeah.
So yesterday when we observed people to see what part of them moved, what I noticed was I'd go, oh, that part of you is not moving, this part or this part. And what I was seeing was actually the whip around the central axis, which is not doing much movement while those other bits do. Good.
Yep.
just wanted to ask if we can expand a little bit around this whip that I connect to the spiral movement.
Yes.
Can we expand a little bit?
Yeah. Oh, you want me to elucidate? You use the word we. I think, okay, we can talk about that. In which direction? Give me a little bit more idea of what you want to understand.
Well, we use our body on the base of a spiral concept. That's what I understand.
Yes.
Is that true? How it is true in Feldenkrais?
How is it true in Feldenkrais? Let's see. This, apart from this movement that you've just done? Oh, okay. So when you read Body Immature Behavior, which you have to remember he wrote for the scientific community. He was trying to establish his play. He was trying to establish, historically speaking, let me slow down, I'm a bit excited. He was trying to establish the things he had discovered within the framework of science. He also wrote a book that was parallel, slightly before or slightly after, which if he had have published that first, it would have been a different ballgame. Scientists would have thought it was just a bit of a... So in that book, he talks about moments of inertia, which is in physics, and please, if there are any engineers in the room, please help me out. Moments of inertia is looking at, so you have a central axis, and then you have different weights distributed away from the central axis. Yes? Now, the closer those weights are to the central axis, the less energy is required to set it spinning. The longer, the further away the weights are from the center axis, the more energy it takes to send something spinning. So the classic school example is you get a long rod and you put a little hook in it, suspend it, so you've got a long rod that way, a hook in it that way, and you try to set it spinning, and it takes a bit of force. But take that same rod, and instead of attaching it in the middle of the rod that way, you attach it so that the rod's hanging down. So the hook's at the top and the rod's just hanging down like that. Easy to spin the rod. Nothing. So that's why when I talked yesterday, I mentioned yesterday about ice skaters, that as they bring their limbs in, they haven't applied any more force. It's just that the weights are being brought into the center, and suddenly all that force is able to spin that dancer or ice skater a lot more rapidly. Now, let's apply this to the movement you've been doing, which is this one. Yeah, you know this one, taking your legs behind? Doing this with your legs long all the time not only gives you those nasty, nasty things on the bottom, but it actually takes more work. So by just you simply bringing in the legs and then lengthening, can you already seeing your, not an imaginary axis through the body, but an imaginary axis through the spin, you're already bringing things closer. That energy gathers, you spin quicker. So that's the mechanical principle involved. And if you look at the human frame, you're an engineer, aren't you, Jenny? You can talk about this better than I can. Ladies and gentlemen, we invite you to this beautiful show today, where we will now explain the principle of mechanical rotational forces through the axial skeleton, presented by Jenny Evans. Okay. Okay, go for it. No. But we can do it like this. Look, we can do it like this. If I suspend him from up here, if I take him off his ass, and if I hold him here, and you spin him now.
If he was free to turn, he turns fairly easily. But if we could, in fact, suspend that out there,
that would be harder.
It would take more
work.
More work to get it to turn.
Yep.
Or somewhere in between with a slightly lighter limb.
Yep. And what you notice about the structure Would you agree, Jenny? That here you have a really long central axis standing. Can you see? It's right visible. If we could take away the ribs, that axis would be so clear to you, you wouldn't be able to ignore it. Because what you just see is just this one long column. And suddenly, the organization of the human body becomes really clear. They're organized around a long central axis. Part of our evolution. It's what gives us our advantage. There is no other creature on this planet that can turn around its own longitudinal body axis with its least amount of force as a human being. We're the only creature that does that. Meerkats, they got long noses. They have, right? Got a long snout. So even then, we have very short snout. So he raises this issue in body immature behavior for a very particular reason. Is this what you wanted to know? All right. So.
No, I was thinking about this
idea of spirals everywhere. So if we do work like that, the spiral would be this way. And of course, the whole spinal column is, I believe, working around spirals, because all the movements we do are all...
Yeah, then you wouldn't be talking about the skeleton. You'd be talking about the musculature and how it organizes around the skeleton, because there's then two sets of musculatures. Don't worry about the picture. So you can imagine this. There's a set of musculature that's very deep. And when you look at that musculature, it's almost oriented in the body up-down. Most of the deep musculature, psoas, it's not even deep, the rectus spinae, all up and down. And then most of the big muscles that create the movement, it's like you've taken a bucket of water and you've splashed the skeleton, and it's just like left, right, diagonals all over the shop. So the movement, the muscles that are associated with movement are organized in diagonals, and if you link them together in chains, spirals. But there's also a set of musculature that's really organized longitudinally. So we're organized to do both, which means we can turn around our axis and then organize the movement of our arm on a different circle. This is circling this way, agitating, and that can translate in... Yep. So it's a little bit of musculature, a little bit of skeleton, da-da-da-da-da. But the point I was going to make is he raises this issue for a very specific reason. That if I have a posture or an acture, he likes the word acture, an activity. If I have an acture that all the parts are gathered as closely together to the central axis as possible, my movement is far more efficient than, I can do this really well, you can see this is forward, that's back. Parts of myself are quite away from the center. There's no way I can spin as quickly as I could if I span here. So this is essential to his definition of what mechanically ideal posture is. So then, if you get too loose with this, in other words, if you let things go all over the shop, it's not going to be efficient. But if you stay like that, that's why he picked that lady yesterday. Because did you notice her? She's upright. Power plus. So there's this balance between form and activity. When you know how to form yourself really well, according to, I was going to say structure, but I wanted to add phenomenology in there, and I was trying to, body and experience, mechanics and experience. When you know to form yourself well, then the activity becomes a piece of cake. But then you need to learn how to form yourself well. And then you need to learn how to learn. So in terms of the steps, if you know how to learn, you know how to find the form. Once you've found the form, life becomes easy. So the first step is learning how to learn. That's what you're doing. And eventually, if you stay with the process and have a really crisp idea of what the action is that you're intending, it takes care of itself. You find the form. Some of us take longer times, some of us take shorter times, but we all find the form. And if you continue on in your research, you get closer and closer and closer to what the human frame is capable of, rather than what you've learned in your life. And you actually start to actualize, oh, according to my own structure, relating to my current experience, I'm now I'm more able to do things. That's the progress of it. It's just the way it goes, if you stay engaged. But most of us, I'll put up my hand, most of us, we get to a certain stage and we go, okay, that's good enough. And we live our lives like that. But for those of us who are interested in continuous development, there is no end. Because the form, and this is why I didn't want to say just biomechanics, the form also includes your experience of what's going on. So you might be biomechanically perfect, but that doesn't mean that the quality of what you're doing can't be senses better and better and better. So there is no end to the improvement of the quality. That's why it wasn't just the biomechanics.
That's interesting. When I say structure, I'm
You're
thinking of biomechanics.
yeah, okay. So that's where, yeah, so you say structure and I think biomechanics. It's interesting. All right. Well, that was a long answer to a short question. But all these materials are in his books. And he has sometimes a direct way of writing and sometimes quite indirect, and that's what we're going to discuss now. We're going to discuss that chapter, structure and function. And you're going to, when you read his work, you come up against all sorts of things. Yep. That's where discussion with colleagues and peers is really, really good, because this is how you sort things out. Do we need a break? Do we have time for a break? Oh, we don't need a break. Okay, let's go into, split up into 1, 2, 3 groups. Find yourselves a place in the room, and then Jenny and Lisa and myself will come over and we'll have a talk with you and listen to what you think. Three groups.